This video lesson is for Chapter 2, Molecules and Solutions. Part 1 is about ions. Let's look at the cartoon first. Here we have a beautiful classroom and the teacher is asking, perhaps one of you gentlemen would mind telling me just what is outside the window that you find so attractive. So let's see if you guys can answer that question properly as we go through those notes. 1.1 Ions. First, let's remember, what is the charge of all atoms? Well, we said it was neutral. It's 0 for all of them. And why does it have that charge? Well, an atom has the same number of positively charged and negatively charged particles. So that means you have the same number of protons and electrons. So when you add up those charges, the charge is always equal to 0. That was true for all atoms. Now about ions. How are they different from atoms? Well, ions are atoms that are electrically charged. So they have a positive or a negative charge. Now how do they become charged like this? It's simply by either gaining or losing electrons. For example, sodium, represented by Na here, would turn out to become the ion Na plus 1. We don't write the 1, by the way. You don't have to. On the right side, magnesium Mg would become the ion Mg2 plus. Now, the atom chlorine would become the ion chloride. I did say chloride, and that's -1. While the atom nitrogen N would become the ion called nitride, which has a charge of 3 negative. And now you might be wondering, why would Na become just +1, and why is it exactly -1 for chloride, and why is it +2, and why is it -3 for that one? Well, we're going to try to discover that over the next slides. Let's look at a few characteristics of ions. So we have only two kinds of ions to look at. We have negative ion, and to become negatively charged, would an atom lose or gain electrons? Well, it's going to gain electrons. Of course, if you're going to become negatively charged, it means in the end you need to have more electrons than protons. And the charge will be negative, and we're going to give them a special name. We call them anions. On the right side, positive ions. How does an atom become positively charged? It needs to lose electrons. And in the end, that means if you lose electrons, you're going to have less electrons than protons for that positive ion. So the charge becomes positive because you have fewer electrons. And the special name is cation for all positive ions. And B, why and how do atoms become ions? Well, atoms form chemical bonds with other atoms. And by doing so, each atom acquires the electron configuration of a noble gas. Noble gases are special because their last shell is full, which makes them very stable. So all other atoms are trying to acquire that configuration. They all want to be more stable like noble gases. And to do so, they must either gain or receive electrons, and they have to bond with other atoms to do so. So let's look at the oxygen atom, for example. So remember, we want to have a last full shell like a noble gas. So on the last shell, it has 6 valence electrons, so it's missing 2 in order to be like neon, which has a full shell with 8 valence electrons. So we're going to draw oxygen again. The nucleus never changes. You cannot change what that is. The protons are too deep inside. So that's 8 protons, 2 electrons on the first shell, and on the last shell, we used to have 6. Now we're going to add 2 more this way, and we're going to show that these 2 came from somewhere else. So these had to come from other atoms. But at this point, if you look at the last shell for oxygen, it is full just like neon, which makes oxygen more stable, and that's what it's trying to do. Now let's take nitrogen for example, and let's see if we can figure out what it's going to do to be like a noble gas. And to be like a noble gas, again, means to have your last orbit full. That's the goal of all atoms. That's why they become ions, to be more like a noble gas. So first option for nitrogen, will it gain electrons? Let's try that one. On the left side I have the regular atom, 7 protons and 7 electrons, so the charge is neutral, 0. So first option, to have the last full orbit, which has 1, 2, 3, 4, 5 valence electrons, you could add 1, 2, and 3 electrons. So that's one way of being like a noble gas. Now the last orbit is full. On the right side, now, could it lose electrons to be full like a noble gas? Let's try this. Again, on the left side you have the regular atom. So I have 1, 2, 3, 4, 5 valence electrons on the last orbit. And so I could lose all 5. And underneath, I would have a last shell that's full also. But now which one is it going to do? So does nitrogen gain an electron or does nitrogen lose electrons? Well, nitrogen, which one do you think is easier? Is it easier to get 3 new ones or get rid of 5? And think about that. When we say get rid of 5, it means that each 5 electrons here that are leaving, you must find a space for them. They can't just leave. They have to be going to another ion, another atom that's gaining a charge. So it's actually easier to just gain 3 more. So this is what nitrogen going to do. It's going to gain electrons all the time. But that's the case of nitrogen. They're not all like that. And nitrogen will take the electron configuration of which noble gas? So if we look again at on the left side, where it gained 3 electrons, if you compare the electrons, it looks exactly like neon. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, but it's still nitrogen because the 7 protons haven't moved. It's still the same element, but now there's a charge of -3. So that's called nitride. It's an anion with a negative charge of 3. Now let's try to represent a few ions using the well-known Rutherford-Bohr model. We're going to start with sulfur and aluminum as well. So what I did each time is I drew the regular atom with 16 protons and 16 electrons for sulfur, and I did the same thing for aluminum. So you could start with that. And then we're going to show how they become ions. Sulfur on its last orbit has 1, 2, 3, 4, 5, 6 valence electrons. So to have a full shell, and that's to be like a noble gas. We've said that all atoms are trying to be like noble gases. So they're all trying to either gain electrons to have a full shell or to lose electrons to have a last full shell as well. So for sulfur with 6, it needs only 2 more. So it's going to be a gain of 2 electrons, and we're going to represent that ion, which would be called sulfide, with the Rutherford-Bohr model. For aluminum, here we have the regular atom with 13 protons and 13 electrons, and the total charge would be 0 for a regular atom. But aluminum has 1, 2, 3 valence electrons, so to be full, it's going to be easier to lose 3 electrons, and that's easier than having to gain 5 to have your last shell full. And when it loses the 3 valence electrons, you get an empty shell at the end. Now we did say that the goal was to have a full shell at the end, but look underneath. That last shell is full. So it works out. So we have aluminum, it's a positive ion, it's a cation with a 3+ charge. And at the bottom, which ions do the following Rutherford-Bohr models represent? Well, with a 9+ charge in the nucleus, you know that's fluorine. And here with a 12+ charge in the nucleus, you know that's magnesium. But you have to count your electrons then. On the left side, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we do the calculation here, protons plus electrons, I have 9 positive charges and 10 negative charges, so the total is -1. So this is actually an ion of fluoride. not an atom of fluorine. On the right side, let's count those electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, if you do your total protons plus electrons, I have 12 positive charges minus 10. So that's just a total of positive 2. So the final ion for magnesium is positive 2. And this table will show us the tendency to gain or lose electrons of all elements that we can study. So here's the trick, guys. You got to know this one very well, okay? If you are an element in group number 1, so these guys are the alkali metals, you have one valence electron in group 1, so your tendency will be to lose one electron. And what does that do? If you lose one electron, your total charge is now positive 1, like lithium. In group number 2, they have 2 valence electrons, so the tendency is to lose 2 electrons, and the charge you gain is positive 2. These are the alkaline earth metals. In group number 3, they have 3 valence electrons. They would tend to lose 3 electrons and become positive 3, like aluminum. Group number 4 is special because here anything can happen. They all have 4 valence electrons. Now what's faster, to lose 4 or gain 4 to have a total of 8? Well, both are as valid, so they could either lose or gain 4 electrons. So carbon could become negative 4 or positive 4. It could go either ways. For the other groups, it's a different story. In group number 5, they all have already 5 valence electrons, so they're getting closer to 8 valence electrons already. So what do you do if you already have 5 and you gain 3 electrons and you become negatively charged 3, negative 3? Group number 6, 6 valence electrons. To have 8, they only need 2 more. 6 plus 2 is 8, right? So your total charge is now negative 2. And in group 7, with 7 valence electrons, they're going to tend to gain only 1 to have 8, right? 7 plus 1 is 8, and the total charge is negative 1. And for group 8 or 18, the noble gases, well, they already have a full shell, right? Helium, I know helium is not 8. Helium is full with 2 electrons, but that's a full shell anyways. So there's no tendency for them, and something like neon, for example, does not become an ion. They don't react. 1.2, polyatomic ions. You have a star next to that one, so this is an EST section, and the rest of your note package is all EST. So what's that, a polyatomic ion? Well, it's just a group of atoms which is charged. If we break down the word polyatomic ion, we see the meaning in the word. Poly means many, atomic is for ion, for atoms, and ion means charged. So many atoms that are charged, a group of atoms that are charged, basically. So you have to know these, basically. So here are the groups we need to know. We have CH3COOH negative 1, that's called acetate. HCO3 negative 1 is called bicarbonate. That's ClO3 negative 1, it's called chlorate. OH negative 1, hydroxide. We'll put a star next to this one because you see that a whole lot. You need to know this one. Hydroxide, very important. NO2 negative 1 is nitrite. That's different than just nitrogen. If you have the ion nitrogen, which is negative 3, the name is nitride. But that one, NO2, is nitrite. The ending is different. SO4, 2 negative, is sulfate. Back on top on the right side, NH4 plus. Put a star next to that one. This is an exception. It's the only polyatomic ion with a positive charge. So this one will replace substances such as sodium because they have the same charge, or lithium. Okay, so they would be playing the role of metals basically, because metals tend to gain a positive charge. CO3 negative 2 is carbonate. CrO4 negative 2 is chromate. NO3 negative 1 is nitrate. PO4 negative 3 is phosphate. And SO3 negative 2 is sulfite. Again, watch out here. The ion for sulfur would be sulfide, and this is sulfite. Now, if you want to be able to identify and name polyatomic ions in a chemical formula, here's what you can do. So if we look at NaOH, you recognize that Na is a single ion, that's sodium. So you can split right after that one. So you have Na plus, and whatever is left is your polyatomic ion. We will only look at groups formed with two parts. So first part here is positive, and the second part here is negative. There are always only two parts. So once you've identified the beginning, which is always positively charged, you can identify the end, which is your polyatomic ion. So this one is hydroxide. It might be the most common polyatomic ion you're going to see this year. Then MgSO4, we recognize it's magnesium, Mg2+, so the rest is the polyatomic ion, SO4 2 negative. And note something interesting here, that my Mg has a 2+ charge and SO4 has a 2 negative charge. So the total is still 0. And if we look at the first one, Na is positive 1, OH is negative 1. The total is still 0. Third one, H3PO4, we have hydrogen, so that's H+. I know it's there 3 times, but each hydrogen is a +1 ion. And so your polyatomic ion is PO4 3 negative. Now, 3 negative plus 1, that doesn't work, but like I said, you have 3 ions of hydrogen. So that's a 3 plus charge in total. And they still cancel. 3 plus versus 3 negative. The charge is 0 in total. And the last one, HCH3COO, which is a kind of an acid substance. You have hydrogen at the beginning, H+, and the rest is CH3COO negative. So that's called acetate.